Let's go on to the server talk. This is probably the piece of networking that's going to get the least service in this, if you'll pardon me, in this conference, partially because servers aren't really file systems in some sense, and partially because we just kind of ran out of time and people to talk about things. Partially because we don't have any documentation at all about servers. I'm going to talk about a couple of things. One of the things that my slides don't have in them that I thought was probably important, and there's already been a couple of questions asked about it, was the concept of a user mode server. I approached this talk from the standpoint of talking strictly about kernel mode servers, components that ran within the operating system and were servers. There is a very large class of applications that's actually fairly interesting that you can characterize as a user mode server, i.e. a service, some kind of process running on Windows NT that services requests from multiple users. And before I dive into the kernel mode piece of this, I'd actually like to take a minute or two and talk about those particular types of servers, and especially some stuff that we've done with Windows NT 3.5 to make those more efficient. Writing code that makes effective use of multiple processors, and I'll talk about this in the context of using multiple processors effectively, because that's really probably the most interesting thing. Typically, people want to run servers, RPC servers, some kind of user mode file servers, that sort of thing. Typically, people want to run those on big multi-processor systems. Windows NT makes this possible. One of the things that's always a consideration, especially in Windows NT, where threads are actually fairly expensive in Unix terms, is how do I go about implementing a server that makes proper use of the number of threads that I have available, the number of processors I have available, and doesn't either have a whole pile of threads hanging around that are doing nothing, or have too many threads so that I wind up starving my clients. In Windows NT 3.1, we believed that scalability in servers was actually well serviced by the standard asynchronous I/O routines. And in fact, that you could do in user mode again, I'm speaking strictly user mode here, you could do a wait for multiple events or wait for a single event with multiple threads and have an efficient mechanism for dealing with multiple clients talking to fewer than end clients talking to fewer than end threads. Turns out that's not the case. There are some inefficiencies in the scheduler. Perhaps inefficiencies is the wrong word. There's some overhead in the scheduler that makes it less than optimal to support multiple clients that way. So we looked at this problem fairly intensely. We spent a fair amount of resources talking to our own SQL Server group, and we came up with a set of APIs that we've implemented in Windows NT 3.5. They're actually documented in the SDK, but not really talked about very much. And that is asynchronous I/O with completion ports. If you look in the SDK, you'll see a set of completion port APIs. There's create I/O completion port, create I/O completion port. There is, I don't remember the names of the other APIs, but there's a wait on completion I/O completion port, and there is a way to, in the asynchronous, the overlap structure in read and write, there is a way to specify a completion report as your synchronization object. When you do that, the Windows 32 subsystem cooperates with the kernel to effectively make the number of threads that are running on the system in your server effectively the same as the number of processors that are available to service you. And the way it does that is by effectively removing the completion of an I/O from the thread that originally queued it. So you can have multiple threads doing I/O for a server, and then have these threads, after they've queued, for example, a read, or I'm sorry, queue to write, or read for that matter, can then pull the I/O completion port and see if there is an I/O completion for them to service. And if there is not an I/O completion available for them to service, they will block. Now, this doesn't sound like a particularly big win, but where the kernel and the Windows 32 subsystem conspire to make this a win is that when a thread comes through and checks the I/O completion port to see if there is an I/O completion, if there is one, that thread will get that I/O completion and service it. If there isn't one, that thread will be blocked, and it will go on a FIFO. No, it will go on a LIFO queue, so that if there are more threads available to service requests than there are requests coming in to keep threads busy, some threads will be blocked, and the threads that are blocked will tend to stay blocked. Okay. So that what happens is that you gain some wins here. The wins you gain are that the threads that are running constantly tend to be in cache all the time. They tend to have their registers be valid. They tend to have their memory paged in, so that in general you get a lot of efficiency around this completion port I/O mechanism. You're about to see a version of SQL Server come out that actually uses completion port I/O, and that SQL Server is much faster. It also scales a lot better, because it has the capability of making much more effective use of the number of processors in the system. So that's about all I wanted to really say about user mode servers. Do you have any questions about those before we plow on into kernel mode servers? No. Okay. Look around, clear. Yes.
I have a question. When you use completion ports for async I/O, can the completion occur on any processor regardless of where the I/O started?
The question is, if you're using completion port I/Os, can the completion occur on any processor regardless of where the I/O started? And the answer is, yes, it can. The comment is that might actually hurt the scalability of it. And every effort is made to keep it on the same processor. I mean, as much as possible. This is actually an interesting thing to look at. Windows NT, as much as possible, tries to maintain affinity between a particular thread of execution and a processor that it's executing on, because there's some really significant wins in doing that, especially with RISC processors. In general, the CAD will be valid. In general, you will have stuff paged in. In general, if you can gain an affinity between a particular thread and a processor, then you gain some big wins. There's some big wins in doing that. So Windows NT takes some extra steps, does some extra work to make certain that there are, as much as possible, you talk to the same processor or you run on the same processor. That's not always possible, of course, but in general you'll see that. With Windows NT 3.1, it was actually a little too aggressive doing that. And you can see that on 16 and yeah, actually you can see it on 8 processor machines, but you can really see it on 16 processor machines, because you get the first 6 or 8 of them would be 100% loaded, and then it would tail off fairly quickly. Scalability is a lot better in 3.5, so that it doesn't, the processors tend to all be the same busyness. Okay, we're running behind, so I'm gonna crank through this. How many people out here are actually intending to build a server? Okay, and a server in this case means something that either talks to a file system on a local machine, services requests from clients, and may in fact be, in the case of a distributed file system, may in fact be a file system of its own. So I know some of you are actually talking about doing distributed file systems, and in that case you have an interesting problem of you are both a server and a file system. So we'll talk a little bit about this stuff. You've seen the slides, but they're long enough, you can read it. Okay. Servers aren't really file systems. They have many of the same problems. They run in kernel mode. They have to do a lot of the same things. Typically, they make use of file systems lying underneath them. In our case, part of the reason you see that the file systems that we have export the same sorts of interfaces, things like CDFS uses the cache manager, CDFS actually implements a lot of the IRPs, the FSCTRLs that can come into it that probably don't make sense for a read-only file system. are that this way we can guarantee that we can be less intelligent in our servers and simply handle things that aren't implemented as error indications rather than having to say, gee, am I talking to CDFS? Can I really do this thing? Can I really do that thing? Etc. Okay, so servers do have many of the same problems. I'll talk to you in a little bit about the fact that you can integrate your server with a cache manager, for example, and talk a little bit about how that actually goes on. Significant differences in implementation, specifically in that with a server you're typically servicing many more clients than you would ever service with a standard file system. Thread usage in a server. The most natural thing in the world with a server is to use one thread per client. It is not the most natural thing to do in Windows NT because threads are too expensive in Windows NT to do this. It's especially not the case if you're trying to write a server that can handle 1,000 or 2,000 or 5,000 clients, which actually Windows NT is actually capable of doing, given the transports that we have and given some of the classes of machines we can run on. So you have to, right up front in your server implementation, break that very natural paradigm that says, gee, I'm just going to spin a thread for each client that comes in, then I have context, life is good, everything's easy. You can't do that. That's a very good way. As someone was commenting to me yesterday, they didn't see linear performance across NT with 1,000 or 2,000 or 3,000 threads created. And I don't know why that is, but in fact, NT doesn't respond well to having lots and lots and lots and lots, and in this case we're talking thousands of threads trying to run at the same time. And in fact, most of these threads are going to be blocking. So anytime you try to schedule, you're going to be spinning through these threads looking to see if they're in a state that they can be used, and they aren't. Again, if you're going to design your server for performance, you want to make it event-driven. We talked at some length about the receive indications available to you in TDI. In this case, I'm looking at a server that's going to be running across the network, because that's typically when I think of servers, that's the case. But there are similar event-driven APIs that you can use for other stuff as well. We already talked about low thread usage. Make certain you really understand the way your client and server are going to interact. Joe will talk about that more this afternoon, but make really certain you understand the way your client and server are going to interact. There are things you can do that will totally tune your performance that seem really obvious right up front. Some of those things are, especially when you start integrating Cache Manager into things, you can wind up, if you're not careful about the way you integrate Cache Manager in your clients, talking to a server, you can wind up monopolizing the amount of data you start sucking across the network. So you have to be kind of careful. That's kind of a client problem, but it also becomes a server problem. Finally, scalability. This is a balancing act. You have to be very careful about the way you synchronize data structures. There are some common data structures held across everything within a server. You have to be careful about the way you synchronize those things, because it can be, the synchronization can be the death of scalability if you're not careful with the way you synchronize them. A general asynchronous I/O, I've already talked about that some. In general, you want to design your server to do as much as possible close to the event. So when you get a receive indication, for example, and you need to respond to it, do everything you can within that receive indication. Sometimes the data that you need isn't available to you within that receive indication. You may have to go out and page data in, etc. In that case, you're going to have to queue that work off to a worker thread. But in the case of a lot of things that servers do, most of the work can be done in a receive indication. Again, don't do too much. If you start spending a lot of time in DPC, you're going to start tubing the performance of the rest of the system. If you're a standalone server, that's fine, but you really don't want to do that. So it's a balancing act here. There's no general guidelines for it. There aren't that many servers written for Windows NT. I mean, I think there are actually people that have written more servers for Windows NT than we have in this room, which means one. Asynchronous I/O is a good example of doing work close to the event that drives it. Scalability again, asynchronous I/O lends itself quite well to scalability. Receive indications can be occurring on all of the processors in the system at the same time if you have a sufficiently fast data path to it. Okay, and this is both incoming from the network to you and outgoing to the file system underlying you. If you in fact are talking to a Windows NT file system with your server, which you probably will be, making I/O as asynchronous as possible, because you can do it and you can worry about the completion later. This makes scalability much nicer. It's actually possible, since you're running in kernel mode, to use the fast I/O path directly in your server. This is actually quite a nice optimization. You know the magic handshakes you need to know about how to talk to the cache manager and find out if the file system underneath you is using caching. So what you can do is, when you open the file, you can translate that file handle into an FCB pointer, follow that FCB pointer to the FSRTL common header. You know from the last 2 days that you've been looking at the FSRTL FCB common header, say, gee, is this file cached? If the answer is yes, call the fast I/O path directly. Big win. You copy it directly out of the cache. Okay. Use FSMDL read and FSMDL write, which are in the kit that you have, and you can do direct I/O out of the cache without the file system even having to be involved. This is valid. We do this with our server. Okay. This is an enormous optimization. And now I've made you all dangerous. Okay. However, you have to do the same thing that the I/O manager would do in the same case, which is if the fast I/O isn't supported, you have to generate an ERP and you have to queue it to the file system. Yeah.
Going back about the threads, I've seen other servers that actually create their own stacks for running, looks like they make their own operating system internally. And I assume something like that would be
Yeah, the question is, he's seen servers that actually do their own extremely lightweight thread path. Their own extremely lightweight thread package. And that's valid in user mode, but in kernel mode, you don't really have that much control over the stack. So the question is, gee, can you do that in kernel mode? No, you can't do that in kernel mode. But it is an interesting thing that I didn't mention. In fact, there have been some people who have done extremely lightweight thread packages for user mode servers, where they basically manage scheduling their own threads and do that sort of thing. And in fact, yeah, that sort of thing has been done. So, yeah.
Accuracy of server computation. They say that's not
The question is SQL Server a subsystem or a Win32 application? SQL Server is a Win32 application. Yeah. The only kernel mode server that we have at this point in time is the LAN manager server. The quote, when people say server in Windows NT, they actually mean the LAN manager Windows networking server, the network server. You'll commonly hear people from Microsoft refer to the server, and that's what they mean. Okay, so in your server, you've got direct access to the fast path if you want to use it. It's actually not very hard to use. You just have to be careful. If you don't follow the rules, the system's going to fall over. But Daryl talked to you enough about what the rules are yesterday, and David Goebel talked enough to you that you should be able to follow them. You're all file system developers now. Synchronization, you have to be very, very careful about synchronization. You don't want to lock too much down. You don't want to spin lock too much in the way of your data structures. In our server, we tend to have what we call a resource package, which has a pre-allocated ERP, sometimes has a buffer associated with it, and has the file handle associated with a particular connection on a client, or the file handle associated with a particular connection to a client, and those things tend to be the granularity at which we lock. because that actually turns out to give you extremely good scalability. You know, we've tested our server with thousands of clients, so it actually does scale extremely well. Okay. Again, you know, I'll hammer this home once again. Spin locks are the way to synchronize if you're going to be a DPC any of the time. So if you're going to synchronize around event receives, that sort of thing, you're going to need to use a spin lock. Resources are a way you can lock if you're within a worker thread, and you know you're always going to be at APC or lower when you're doing that. And finally, if you're really good, you might actually be able to get away with not doing any synchronization at all. And if you can make things totally disjoint, I mean, this far end of the scale is in fact what people are typically looking at when they do a thread per client. If you spin a thread per client, people tend not to do synchronization of data structures other than perhaps if they have a single queue that they put all of they thread all their data structures on. But this doesn't, again, this does not scale very well. It'd be really nice to have spin lock, but okay. I've already talked about caching. It is possible if you're a server also to do some internal caching. Our server does this a little bit, where it just sucks stuff out of a file and keeps it handy in a buffer internally. This doesn't scale very well, but for some kinds of directory information, for example, or metadata about a file, like get file information, this actually can be quite a win. So you can get directory information, get file information, and cache it internally. Okay. And the purpose of this, again, is to satisfy reads close to the requests. So if I get a request from a client that says, gee, I want to enumerate the files in a directory, and I have that information cached, turn it around immediately. The question is going to be caching by the server or caching by NTFS. In this particular case, if there's two things going on here, right? You're caching the information in the file, and typically you want to let the cache manager do that, and the cache manager will do that. Okay? Because when you open the file, you can specify whether you want to cache or not, and you as the server are in fact opening the file. So since you open it cached,
I meant directory information.
well, directory information is typically something you cache yourself. Okay. Because, again, that's dependent upon how your server works. Because it depends. This is one that is a horrible rabbit hole. But if your protocol is stateful, such that you know what your current root, where you're currently rooted in your directory structure, then it makes more sense for the server to cache it than it does for the underlying file system. So, especially if it's not cached, if it's cached in such a way. The follow-on question to that was, what about coherency of the information you have cached? If you're going to cache directory information, you hang a directory notify on the directory, and then any time it changes, you update your cache. The question is, can that collide with other notifies? It's up to the file system to make sure it doesn't. So, okay, and the APIs that you use to get to the data in the cache manager, FS and RTL, NDL read, NDL write. At least NDL write is documented in the docs that you have that were handed out to you. I'm not going to talk much about impersonation. Rob Rochelle actually covered that pretty well yesterday, I think. So,
as far as server for information, or are they all used to account? How does that work if I want to both the link between the client and the internal
okay. The question is, gee, I'm just a random server and I want to use both Win32 and internal API call in writing my server. What I'm talking about here are strictly kernel mode servers. And the kernel mode servers will typically actually generate an ERP themselves and use an IO call driver to the file system and hand it off to them. If you're doing reads and writes, you don't want to go through any of the APIs because it just you can generate the ERP yourself. You know enough to generate that ERP. Go ahead and do it. I mean, if you're going to go through, if we go back to here and we talk about fast IO, if you're actually going to integrate directly with the cache manager, if you're going to try to talk to the cache manager within the server, well, you certainly have enough knowledge to generate an ERP. If you're intimate enough with the file system that you're actually going in and sucking stuff out of the cache manager directly, then generating an ERP, well, that's not very hard anymore. Because hey, that's the easy way. You can, in fact, if you want to, use the kernel APIs to talk to an NT read file, NT write file. Have been documented in this doc you have. I believe that's true. To talk to the files, but generate an ERP, pound it in.
That's fine on that point. However, it's still a valid point in the sense of performance monitoring.
Yesterday,
Okay. The question is really about performance. How do you monitor performance if you're doing this sort of thing? How do you get performance information out of the NT kernel? And there's information that Mike Warsheim is committed to bring back to you about performance and performance APIs in NT. Yeah.
So, in general question, therefore, can a server or a file system or whatever, can I call
The question is, if I'm in front of the server, can I call in through APIs? No. You could try. I'll Microsoft things back on that. It won't work. Yeah, no, they haven't tried. A very brief bit of history here. Windows NT only gained the Windows API after it was actually booting and running. The Windows NT project, there's a book out about this now called Showstopper, which is I won't say much about the book, but it actually details the process of getting Windows NT out. And in the process of building Windows NT, we did not originally have the Windows API on it. Windows is in fact a subsystem in Windows NT and makes use of underlying kernel calls, and the kernel does not call back out. So if I'm in the kernel and I'm trying to use subsystem primitives, it's not intended to work in Windows NT. If I'm in kernel mode and trying to use subsystem primitives, it's not intended to work in NT. That's not part of the design paradigm. For those of you who didn't know, there's actually a PM subsystem that runs on top of Windows NT as well. If you're really a program or a presentation manager kind of fan, there's actually one that runs on Windows NT. You can buy it for Windows NT today. Yes, it was originally called NTOS2. That was long ago. Okay. Oh, I'm going the wrong direction. All right, here we go. All right, we talked about caching. I'm going to just skim past impersonation here. I think Rob Reichel did a really good job of talking about that. I'd like to get Chuck up here to talk about real cool stuff. Servers aren't really nearly as difficult as a file system to write, but they have their own unique problems, and we'll be documenting what some of those unique problems are as we go along. Security is one of them. Scalability is another, because typically you want to server scale extremely well. You have to do a lot of work to make sure your server scales well. Start paying a lot of attention to where you're actually spending time in your code. Okay. Questions? Yeah, back here. Question about impersonation. I'm sorry?
You talked about that slide.
Yeah, I talked briefly about this slide. I mean, you can totally blow off impersonation, right? I mean, if you're in the kernel, you're in the kernel. So you can actually open files. I mean, you're effectively administrating your local system, so you can open anything effectively and totally ignore access control. So if you wish to implement, if you don't wish to integrate your security with Windows NT in any sense, you can in fact implement, quote, security, unquote, internal to your server.
Is that Landman on the office?
I'm sorry?
Is that how Landman is doing it?
The question is that how Landman is doing it? No, that is not how Landman is doing it. Landman is very tightly integrated into the Windows NT security system. A lot of this Windows NT security system is written around Landman and the way Landman needs to validate.
So it's using impersonation or its own access to the security services.
The question is the Landman server using impersonation? And actually, Rob Rochelle talked about that a little bit yesterday, but yes, the Windows NT server does use impersonation. When it opens the file, it does impersonate the client. And again, since it's a LAN manager client, you can take a look at what that client looks like and use the challenge authentication that comes across the wire and understand what the security, understand what kind of user you're talking to. And it does in fact do impersonation. So, but again, impersonation only occurs, Robert talked about this yesterday, impersonation only occurs at the file level, when you open the file, because that's when the access check is done, and after that, you know what you need to know. So.
I have a question about server structuring, and in particular, I'm interested in the implications and feasibility of recursive servers. Suppose I have a server that runs on top of a file system, and the file system somehow needs to call itself recursively through the server, or perhaps through a recursion loop involving other file systems. Suppose, for instance, you have a chain, you're following a chain of symbolic links that traverse multiple file system types, and you're on the server. How does that work, and what kind of tools are there to set this up correctly?
Well, yeah, the question is really, the data goes round and round, whoa, where does it come out?
Well, no, I think the question is what do you do not to avoid deadlocks and stuff like that, because that's really the issue.
There is no explicit support in Windows NT for doing that kind of thing, but if you design carefully, you shouldn't run into any deadlocks, which of course means you probably will. This is a question that we haven't really answered internally at all. My server talks to this file system, which then talks to that file system over there, which then talks to that server. Intrinsically, the support is there, but it's not something that we've tested or run through. So points that I think you would probably immediately find, you should probably blow out the ERP stacks, things like that. You start locking down massive amounts of data and start running out of physical memory. That'd be the kind of thing that I would expect you'd wind up doing. So this is a question that's not going to get answered in 5 minutes. It's going to take a long time to answer. So
yes, I understand that. But I suppose the first step towards answering the question would be to provide an explicit listing of the NT locking hierarchies in the VM and cache subsystems. I suppose there must be some header file that documents the locking hierarchy. Most kernels that I've seen, most OSs, have something like that. It's either a header file or some module that lists the semaphore hierarchies. Or is that available in the DDK, or will it be available otherwise?
I'm not certain. I mean, the locking ERP is well, it's not necessarily well documented. At least you know what all of the what the ERP looks like and how the ERP works.
No, I'm not talking about ERP. I'm talking about the locking hierarchy through the VM and cache subsystems.
Yeah, I see what you're requesting. I don't think anything like that is available right now, but that's good feedback for the.
Because I think it would be very important to add that to the contents of the DDK or the file system development.
Noted. Yeah, right here.
Is there a problem with latency of directory notifying defined caching structures, like say indexes in memory? Can I use one data?
The question is there a problem with latency in directory notify specifically if I'm going to cache directory information in my server, and am I going to worry about latency? It's up to the, I mean, if you don't implement your, assuming your compatriots here who implement their file systems, don't design their file systems so that they actually notify somewhere down the road that a directory has been updated, then no, you shouldn't have latency. I mean, yeah, there will be latency. That's absolutely true that there will be latency because, and I mean, it might only be a few cycles and it might be thousands of cycles. There will be some latency because you just can't avoid that. But it's up to you. If you're going to do this kind of caching stuff, you're going to play around with caching, then it's up to you to make certain that the latency doesn't occur, or if the latency does occur, that it's not going to affect you. So if you're worried about latency, then you probably can't cache unless you've assured yourself that the latency isn't sufficient to matter to you. And, you know, it's a game, you know. So when there's a time lag between what's happening at your server and what's happening at your client. I mean, the client thinks the state of the server is slightly different than it really is. So that's always absolutely 100% the case in any networked file system. So it's up to you to design your protocol and make certain you understand the effects of that latency on your protocol and the effects of the things you're doing within your server to improve performance on that protocol. Okay. So I guess what I said was it's your problem. One more question, then we're going to take a break. Yeah.
I was told how to respond to outlook-related parts. I got the impression that they were outlook important for writing efficient client server. Do I need to know more about that?
The question is, we got told how to deal with op-blocks, and you got the impression that op-blocks are important for running efficient clients and servers. Op-blocks are important if you're going to cache on your client. That's really what op-blocks are designed for. Remember that an op-block is basically designed to allow your client to say, well, I've got a lock on it, but I'm not really going to maintain a state about the lock on the server. I'm going to the server just knows there's a lock, and the client then sucks all the data locally. So you can start doing all sorts of really random things without having to play games with locking particular ranges within the server. The server simply knows this guy's got an opportunistic lock on it. He's assuming somebody else won't collide with it. So if somebody does come in and try to open that file, then you get a lock break. That's an expensive operation because you've got to tear down the lock and get all that cached information that's on the client back to the server, so the server can now maintain the state. Because that's the only place you can actually legitimately maintain the state if multiple people are talking to the file. Okay? Unless you really want to implement a distributed database of locking information, which you probably don't. So an op-block it's a big win because in most cases multiple people aren't opening the same file. And that's if you want to have a caching client and you implement locks that will support that caching client on your server, meaning you support op-blocking and that sort of thing, and op-blocking can be a really wonderful thing.
So is there an outlook API that you provide that
The question is there an op-block API that you provide other than the op-blockers? No.
So I basically run my own.
Right. Yeah, the question is basically right now, yes. Okay. Let's go ahead and take a quick break and then we'll put Chuck up here and he can tell you what you need to know about running a Beaver.